So in the last class, we discussed the analysis of Quicksort algorithm under best and worst cases. So what is best case running time of Quicksort? QS Quicksort is big omega of n log n. Is this correct? Best case running time of Quicksort is big omega of log n. Is that correct? Best case running time of Quicksort is big O of n log n. Best case running time of Quicksort is theta of n log n. Similarly, worst case running time of Quicksort is big O of n square. Worst case running time of Quicksort is big omega of n square is theta of n square. Out of this, are there any wrong statements among the 6 statements given here? Are there any wrong statements? First one, because in the best case, order of growth of what are the operations we are counting? Comparisons is n log n. In the worst case, order of growth of comparisons is n square. Hence, best case running time of Quicksort is big omega of n log n. This is true. Why? Because n log n is omega of n log n. N log n is big O of n log n. This is also true. N log n is theta of n log n. This is also true. This is also true. This is also true. Why? Because in the worst case it is n squared. This is also true. This is also true. So if I write like this, running time of Quicksort is theta of n squared. Is this correct? Running time of Quicksort is theta of n squared. Is this correct? Running time of Quicksort is theta of n log n. Is that correct? Running time of Quicksort is big O of n square. Quicksort is big omega of n log n. What about the 7th one? Is this true or not? 7th statement?
False, sir.
7th one is false. Why, brother?
Sir, because in best case we have n log n order, sir.
So in the best case it fails. That's why this is not correct. What about 8th one?
It fails in worst case, sir. In worst case we have n square.
What about 9th one?
9th one is correct, sir.
That is true. No, best case also it is true. Worst case it is true. Automatically average case it will be true. Still we don't know what is the average case running time of this Quicksort. Even without knowing that, we can say that it is true or not.
Sir, anyway it will be between best and worst case. So
yes,
we can say.
That's why we can say that. So average case running time will be, the average will be between worst and best. Okay. So hence definitely it will be between n log n and n squared. So definitely this satisfies this. This also satisfies this. This also satisfies this condition. Now, before going to calculate what is average case running time, as I mentioned in the previous class, there are different ways of partitioning this partitioning algorithm. No, there are different partitioning algorithms. I just show you 2 different partitioning algorithms. These are 2 different partitioning algorithms. So some of you Those who have read no Coleman textbook latest edition, you must have seen this type, this variant, and Shahani textbook, you must have seen this. Okay, now one is called Hoare partition, the other one is Lumotow's partitioning method. Whether we use Horace partition or Lumotow's partition, what is the amount of time this partitioning algorithm takes if there are n elements? If n equal to r minus p plus 1, what is the amount of time this Lumotow's or Horace partitioning algorithm takes? This is Hoare. What is the amount of time it takes? What is that we are counting here? Number of comparisons. Whether we go for a Lumotow's method or Horace method, how many comparisons are performed? How many comparisons are performed? How many comparisons are performed? Here it is very much clear now. How many comparisons are performed here? For each value of j from p to r minus 1, one comparison is performed or not? One comparison is performed or not? So what is this value? This can be written as r minus 1 minus p plus 1, that is same as r minus p. We know that n equal to r minus p plus 1, then what is r minus p? You can write it as n minus 1. So in this method, how many comparisons are performed? In Lumotow's method, how many comparisons are performed? N minus 1 comparisons. So similarly, in Horace method, how many comparisons are performed? This is our comparison now. This is comparison. What is the main difference between Lumotow's and Horace partitioning algorithms? What is the main difference? What is the main difference? In Lumotow's partitioning, only we have one index elements we compare from left to right. But in case of this Hoare partitioning method, we have two indices, one from left to right, the other one from right to left. Is that correct? Two indices. One index. Here, both sides we compare elements with pivot elements. Here, only one side from left to right, we keep comparing. We keep comparing. So it is implementation, it is easier compared with the other one. Easier with the compared with the other one. Assume what is the amount of time this algorithm takes? This algorithm takes. What is the amount of time this algorithm takes? This is also, we can say that it is same as theta of n, same as theta, because every other element in the array is compared with which element? Pivot element. Hence, here also number of comparisons we can consider it as n minus 1 or sometimes n, whatever it may be. Okay. So that means roughly we can say that here also theta of n. So from this, what is clear? Partition procedure, it takes only linear time, that is theta of n time, theta of n at time. So then in the average case, what happens? Left to subarray we have and right subarray. What are the sizes of left and right subarrays? If it is 0, it is n minus 1, it is 1, it is n minus 2, it is 2, it is n minus 3, and so on. It is I means it is n minus 1 minus I, and so on. This is n minus 2 means how much is this? How much is this? If left side n minus 2 elements are there, how many elements will be there on the right? Only one. Why? Because left plus right, it should be n minus 1. If there are n minus 1 elements here it will be 0. It will be 0. Is that correct? When does this case occur? Either this case or this case, when does it occur? If array is already in sorted order like this. For this, if you apply insertion sort, what is the time it takes? Sorted array. Sorted array. If you apply insertion sort, it will be in which case? Paste case. Hence the time is only theta of n. If you apply here quicksort, what is the time it takes? It goes into worst case. Hence it is theta of n squared. Now for almost sorted arrays, which sorting method is more useful, whether quicksort or insertion sort? Quicksort or insertion sort? Which sorting method is important, more useful? Insertion sort is more useful. Why? Because it takes only n amount of time. Now, but in average case, what happens? We are interested in average case. So average case. Average case, anything should be possible. No, left side 0 elements, right side n minus 1, or left side 1, right side n minus 2, or on one left side n minus 1, right side 0. Anything is possible. Anything is possible. Next question is, what is the probability that this case occurs? What is the probability that this case occurs? This case means this. This case means this two. What is the probability that this case occurs? And this one, what is the probability that this case occurs? What is the probability that this case occurs? Now, if you assume that it is uniform distribution and there is equal chance of any case occurring here, equal chance of any case occurring here. That means any element is, in this case, which element is pivot? Which element is pivot? In the first case, which element is considered as pivot element? If left side there are 0 elements, right side n minus 1 means which element we must have considered as pivot element? Left side there are, that means this occurs when smallest element is considered as pivot. No? Smallest element or minimum element. Is that correct? For example, if 10 is chosen as pivot, then what is the array? 10 will be here, this side smaller, this side larger. So now how many elements will be there if 10 is chosen as pivot? Left side 0 elements, right side how many elements? 5 elements. Is that correct? So that means if smallest element or minimum element is chosen as pivot, then left side 0 elements will be there, right side. And what is this? In general, we can say that it is, if pivot is minimum, pivot is the minimum element of array. Minimum element of array. Then left subarray contains 0 and right subarray contains how many elements? N minus 1. This is one point. Similarly, if pivot is maximum element, If pivot is maximum element, then what happens? How many elements will be there in the left side? And how many elements on the right side?
n-1 left,
N minus
0 right.
1.
N-1 left side, 0 right side.
0.
Okay. But when we go for average case, all possibilities we need to take. Now we assume that any element becoming pivot, it has equal chance. If there are n elements, whatever the probability that first minimum element is pivot, whatever same thing is the probability that second smallest element is pivot. Same thing is the probability that third smallest is pivot, and so on. Same thing is the probability that last element is pivot. Then when we go for average, then what is that we need to do? In this case, how many comparisons are performed? We need to calculate. Second case, number of comparisons. Third case, fourth case, and nth case also we need to find number of comparisons. That means what? First case is same as T of 0 plus T of 1, n minus 1. Sorry. In the first case, what is number of comparisons? T of 0 plus T of n minus 1. What about second case? What is second case? Number of comparisons in second case? T of 1 plus T of n by 2, n minus 2. Third case, T of 2 plus T of n minus 3, and so on. This is one case. What about last case? What is last case? T of n minus 1 plus T of 0. Okay. But in order to arrive at this case, before dividing, what is the amount of work we need to do? Before it happens, we need to do how much amount of work? N minus 1 comparisons we need to do. No? Here also n minus 1 comparisons we need to do. Here also n minus 1 comparisons we need to do. And so on. Even here also n minus 1 comparisons we need to do. That means partition. After that, the array is partitioned into 2. Is that correct? Is that correct? Is there any doubt? Is there any doubt? Because we assume that simple uniform distribution, each case it has same probability of occurrence, then what is average case running time? So therefore, what is average case running time? T of n equal to answer in first case plus answer in second case plus answer in third case and so on, answer in last case divided by total number of cases, no? Average. So what is this value? What is this value? N minus 1 plus sigma I equal to 0 to n minus 1. Can we write something like this? T of I plus T of n minus 1 minus I whole divided by n. Okay, so this n minus 1 also there only, no? N minus 1 also should come, no? Equal to sigma I equal to 0 to n minus 1 like this. Is that correct? Is that correct? T of n is sigma I equal to 0 to n minus 1, T of I plus T of n minus 1 minus I by n. That means answer here plus answer here plus answer here plus answer here divided by n. Why? Because there are total n cases. What is this value? What is this value? Can we simplify this? 1 by n, it is independent, we can take outside. It is sigma I equal to 0 to n minus 1 plus sigma I equal to 0 to n minus 1 T of I plus T of. Is that correct? Is that correct? Is that correct? Now what is the summation expression value? What is the summation expression value? What is this value? What is the value of that?
N minus 1, sir.
N minus 1 or n minus 1, n into n minus 1?
N into
Yes.
n minus.
N into
N
n minus 1. So we know that sigma I equal to 0 to n minus 1. N minus 1 is n into n minus 1. Is that okay? So already 1 by n is there. Here n into n minus 1. So n gets cancelled. This entire thing simply we can write it as only n minus 1. Is that correct? So what is 1 by n into this? Into 1 by n, which is same as n minus 1. Is that correct? Is that correct? So therefore T of n can be written as T of n can be written as, let me write here only. T of n can be, I'm writing here. T of n can be written as n minus 1 plus 1 by n into sigma I equal to 0 to n minus 1 T of I plus T of n minus 1 minus I. Is that okay? Is that correct? So by solving this reconciliation, we can show that order of growth here is order of growth of T of n is n log n. That means what is worst case average case running time of a quicksort? What is average case running time of quicksort? What is the average case running time of quicksort?
Big omega of n log n.
Big omega of n log n, correct. Thank you, sir. Any other answers? Any other answers? Big O of n log n also correct. Theta of n log n is also correct. So average case running time of quicksort is same as usually average case is same as worst case running time, most of the algorithms. But quicksort is very special where average case running time is same as best case running time. Is that okay? That means on average this algorithm works very well. But in the worst case, it is again same as bubble sort, selection sort, and insertion sort. But in the on average, it works very well. Okay. Now we'll check, are there any cases in which its running time is again n log n? Okay, that's what we check now. So before moving on to that, what is selection problem? What is selection problem? Try to understand what does selection problem mean. If you are given an array of 5 distinct elements, this is input. What is sorted order of this? Eight, 10, 12, 16, 24. This is sorted order. So now, in this sorted order, what can you say about the first element? In the sorted order, what is the first element? Which is same as minimum element of given array, minimum or smallest element? Is that correct? What can you say about last element? Maximum or largest element? What does minimum element mean? That means it is an element in the array which doesn't have any other elements which are smaller than this element. No, that is the meaning. No, what does minimum element mean? It is an element in the array which is not greater than any other elements. Which is bigger than any other elements in the array. That is the meaning of smallest element or minimum element. Similarly, what does maximum element mean? It is an element in the array which is greater than all other elements in the array. If there are n elements, which is greater than n minus 1 other elements. Is that correct? Another way of saying what is maximum. Is that correct? Now look at 10. What can you say about 10? Element 10, which is greater than how many elements? Which is greater than how many elements? Which is 10 is greater than how many elements?
One element.
Only one element. No, 10 is greater than only one element, that is 8. Similarly, if I take 12, if you take 12,
It is greater than two elements.
Two elements. What are they? 8 and 10. 16 is greater than 3 elements. 8, 10, and 12. 24 is greater than 4 elements. Is that correct? Now, can we generalize this? Okay. What is this 10? Can you call it as second smallest element? Second smallest element. Is that correct? That means, what does second smallest element mean? It is an element in the array which is greater than at exactly one other element of the array. Is that correct? So 10 is second smallest in this case. Is that correct? 10 is the second smallest element. Is that correct?
Yes, sir.
What can you say about 12? 12 is greater than exactly two other elements of the array. That means 12, we can consider it as, is it second smallest or third smallest? Is it second smallest or third smallest?
Third smallest.
Third smallest. In general, if we are given n distinct elements, okay, na? And if you find an element of that array which is greater than I minus 1 other elements, then we say that is what? Ith smallest element. No? I equal to 1 means it is same as minimum element. I equal to n means it is same as maximum element. Is that clear, or any doubt in this? What does second smallest mean? What does second smallest mean? It is an element.
One element in the
It is greater than exactly one element in the array. Is that correct? What does fourth smallest mean? What does fourth smallest mean?
greater than 3 elements in the array.
3 elements in the array. So if we sort the elements in order, no, non-decreasing order. Non-decreasing order. That means, say, if all are distinct, that we call it as increasing order. Then 8 is first smallest element, 10 is second smallest element, first smallest. This is second smallest. Can we say something like this? Is that correct? This is second smallest. This is third smallest. This is fourth smallest. This is fifth smallest. Is that correct? And this problem is known as selection problem, or simple terms, this is finding ith smallest element. Ith smallest element. Ith smallest element. That problem is known as selection problem. If I equal to n by 2, then it is called median. Median. Is that okay? Is that okay? If there are 7 elements, how many medians will be there? If there are 5 elements like this, how many medians will be there? What is the median of the array?
One element.
One element. What is that element in this case? What's the median?
12.
12, no? If there are 6 elements,
Then
we have 2 medians. One we
three
call
and
it as,
third and fourth element.
one we call it as lower median, the other one we call it as upper median. Okay, if n is even, n plus 1 by 2 the smallest element, we call it as median. Is that correct? If there are 6 elements, what are medians? What are medians? If there are 6 elements, what are medians?
Third and fifth.
Third and fourth, no?
Fourth.
Third and fourth. This third, can we write it as n by 2? Fourth, can we write it as n by 2 plus 1? Is that okay? This is when if n is odd,
Directly n by 2.
no, this is n is odd case, no? This is n is odd case. N plus 1 by 2.
Okay.
Correct, no? N is 5 means 5 plus 1 by 2. N is even means?
Okay.
N is even means n by 2 and n by 2 plus 1. This we call it as lower median. This we call it as upper median. Is that okay? Is it clear what is selection problem and what does ith smallest element mean? What does ith smallest element mean? It is an element in the array which is greater than I minus 1
I minus
of array.
elements.
Okay, I equal to 1. First smallest means it is same as minimum. Nth smallest means it is same as nth small. There are n elements and the nth smallest element is called. There are n elements, then the nth smallest element is called
Maximum element.
maximum element. Maximum. If there are n elements, loosely speaking, n by 2 the smallest element is called
Median.
Median. That is median. That means if n is odd, if you find median, half of the element will be one side, other half will be the other side. Okay. Next question is, now we calculate running time of Quicksort under different conditions. Running time of Quicksort. Different cases. Okay, different cases. So the first one, if always pivot is chosen as first smallest element in the remaining array. First smallest element. That is minimum element of the remaining array. Is that okay? Always pivot is first smallest element, that is minimum element of the array to be sorted. In that case, then what happens? What happens if you apply quicksort? Every time first minimum element only we choose as pivot. If we choose minimum element as pivot, after the partition procedure is over, how many elements will be there on the left side? How many elements will be there on the right side? How many elements will be there on the left side?
One element.
This is a
Zero
pivot.
elements, sir.
Zero, sir.
Zero.
Zero.
This is pivot. This is 0 elements. How many elements will be there on the right side?
N.
-1, sir.
N minus 1. Total n we are assuming, no, total number of elements. Now what is time in this case? It will be t of 0. This is t of n minus 1. So what is recurrence relation? Partition, anyhow we know that it is theta of n or n minus 1, whatever we want we can write. So what is the recurrence relation? T of n is n minus 1 plus t of 0 plus t of n minus 1, which is same as, okay, I'm writing order of growth, it is n squared. Is that correct? It is same as worst case. Is that correct? Now always if we take pivot as nth smallest element, which is same as maximum element. Now how many elements will be there on the left side? Left side, right side. How many elements after the partition?
N minus 1.
N minus 1, thank you, brother. Here, 0. Is that correct? Why it is 0? So our array is 20, 10, 25, 40, 30. If we choose 40 as pivot, how many elements will be there on the right side? Right subarray? How many
Three
elements will be there on the right
Sir,
subarray?
one element. One element.
No elements at all, no, sir. See, this is left subarray. This is pivot position. This is right subarray. So pivot 40 comes here. Right subarray, are there any elements which contains elements which are greater than or equal to that? No. Are there any other elements?
No. Okay. Yeah.
No. That
No.
is 0. Okay. For easier calculation, we assume that all elements are distinct, so that equality, whether we bring that side or this side, that confusion will not be there. Okay. So it is 0. Now what is the reconciliation? Is it same as this? Same as this or not? Is it same as that or not? Is that okay? Instead of t of n minus 1 plus 0, we'll get t of 0 plus t of n minus 1. Both are same or not? Both are same or not? N minus 1 plus t of 1 plus t of 0 plus t of n minus 1 plus t of 0, which is same as, again, order of growth is n square. That means, is it same as first case? Now, instead of this, if you always choose second smallest element as pivot, second smallest element. So please directly tell me what is the recurrence relation. How many elements will be there on the left side? How many elements will be there in the left subarray?
1, sir.
1. So recurrence relation will be t of n equals to t of n minus, okay, sorry, t of 1 plus, how many elements will be there on the right side?
3.
3.
N minus 2, sir.
Total this side 1, total will be n minus 1. This is pivot. Total is n minus 1. So here only n minus 2 if I put, then only 1 plus n minus 2 is n minus 1 now. So it will be T of n minus 2 plus n minus 1. Is that correct? Is that correct? If we always choose second smallest element as pivot, then what is the reconciliation? T of n is T of 1 plus T of n minus 2 plus n minus 1. What can we say about its order of growth? What can we say about its order of growth? What can we say about its order of growth? Any clue? T of 1 is constant. Okay, now T of 1 is some constant. No. If it is n minus 1, we know what is the answer we get, no, n squared. It is n minus 2 is there. So can
we write n square?
This is also okay. I'm not going to do that, but simply we can show that if you do repeated substitution, no, this we can replace with constant. Repeated substitution, we can show that it is also order of growth is n square. It is same as worst case. Is that okay? Now instead of second smallest element, if you choose third smallest element, what is the reconciliation? What is how many elements will be there on the left side?
2.
2. So T of 2, right side. Left plus
3.
right is n minus 1.
N minus 3.
N minus 3. Then only n minus 3 plus 2 is n minus 1 plus n minus 1. What can you say about its order of growth?
N square.
It is also same as worst case. Now instead of that fourth smallest element, what is T of n in that case? How many elements on the left?
3.
Right?
N minus 4.
Plus n minus 1. This is also order of growth. We can say that it is also n square. It is same as worst case. Instead of this, if I choose 100th smallest element, how many elements will be there on the left side? 100th smallest element. How many?
99.
So T of n will be T of 100 minus 1, that is 99, plus total
N minus 100.
99 minus 1, no? N minus 1 minus 99 plus n minus 1. What can we say about its order of growth?
N square, sir.
It is also order of, thank you, sir. Okay, order of growth is n square. It is same as worst case. That means any fixed constant, okay, no, that is element that we choose, smallest element, if we choose as pivot every time, then it is going to take n square amount of time. N square amount of time. So now instead of 100 small, okay, let us talk about second largest, which is same as n minus 1th smallest. Both are same, no? Second largest, is it same as n minus 1th smallest?
Yes, sir.
I think this is clear, no? Do you want me to give an example for this? No. Second largest, it is same as n minus 1th smallest element. Now in this case, what is T of n? Please tell me. How many elements on the left and how many elements on the right? Whichever smallest element you take as pivot, that smallest element minus 1 number of elements will be there left side. Is that correct? Now how many elements will be there left side? How many elements on the left?
N minus 2.
N minus 2. How many elements on the right? Total is n minus 1. One side it is n
One
minus
element. One
one
element.
element. As usual, it is n minus 1 fixed. Again, order of growth is n square. Instead of that, if I choose third largest element as pivot every time, which is same as n minus 2th smallest, what is T of n?
T of n minus 3 plus T of 2.
Thank you, sir. Plus n minus 1. Again, order of growth is n square. In general, if I choose n minus some constant, where this constant is between this is smallest. If we choose as pivot, then what happens? That it's a constant means not function of n, not a function of, it can be 1 crore or 10 crores, but not in terms of n it is defined. It is independent of n, not a function of n. It is independent of n. In this case, what is the reconciliation? What is the reconciliation? How many elements will be there in the left side?
N minus constant minus 1.
Constant minus 1. Thank you very much, sir. Right side?
N minus constant plus 1.
No, sir.
Constant, sir.
Only constant, no?
Sorry, constant. Yeah.
If we add 2, no, we should get n minus 1, sir. That is simple. Plus n minus 1. Now, can you say something about order of growth in this case?
It is also n square.
It is also n square. If you want, you can replace with any constant. Okay, no? It is also n square. That means is it only case where array is sorted order or array is in the reverse sorted order? Are these the only two cases in which Quicksort takes n square time, or are there different cases where it takes still n square? There are many cases in which it takes n square amount of time, no? N square amount of time. Now let us look at the case where every time it takes median as pivot. Median, that means n by 2th smallest element, where n is number of elements. But after subarray, n value changes. Okay, no, that's why it is better not to write n by 2th smallest element. Okay, the same thing is true here also, no? Okay. Now tell me what happens if median is chosen as pivot element. Median is chosen as pivot elements. How many elements will be there on the left and how many elements on the right?
N by 2 minus 1. Left side.
So in even odd case, okay, no, we can appropriate. In even case, median means only lower median we consider. Okay, now you tell me how many elements will be there in the left side? 1 to n we have elements. If I take median as pivot, how many elements on the left side?
Median minus 1, sir.
Median is value, no, brother. Median
Okay.
is value, no. It's not index.
N by 2.
N by 2 or n by 2 minus 1, depending on say.
Yes.
So one side, if it is n by 2, what can you say about other side?
Also same, sir. N by 2 plus 1 or minus 1.
No, one side, if you fix other side, we should be able to give easily, no?
To minus 1, sir, in other side.
N by 2 minus 1, no? Why? Because if we add both, we should get n minus 1. That is simple logic, no, sir? N by 2 plus n by 2 minus 1, n minus 1. So plus
But
n
if
minus
exactly it is odd number of values, odd number of elements, then both sides it would be n by 2. The value of n is odd.
Okay, with odd value. Okay, yeah, that means then the floor, ceiling, all those things will come to picture. Here assume that n is of the form 2 power k. Even then we cannot give that guarantee. It doesn't work exactly. Okay, let us write exactly then in that case. 1 to n means n plus 1 by 2 the smallest element. No, that means what? N plus 1 by 2 minus 1 number of elements one side. What can you say about number of elements on other side? N minus 1 minus n plus 1 by 2 minus 1. Is that okay? If it is left means this is right. Is that correct? Is that correct? This is when the odd case. N is odd case.
Yes, yes.
N is odd case. So plus 1 minus 1 gets cancelled. 2n minus n minus 1. How much we get? This gets cancelled. N minus 1 by 2. Is that correct? Is that correct? Oh, this is also same, no? N minus 1 by 2 only, no? Is that correct? Is that correct? If n is even, if n is even, if n is even, lower median if I take, if there are 6 elements, say for example, 1 to n is say 6, so this becomes our lower median. So what is that? N by 2 smallest element. That means left side, how many will be there? N by 2 minus 1. This is left side. Right side, n minus 1 minus n by 2 minus 1. This will be n by 2. This will be true for n even. Is that correct? If n is odd, t of n minus 1 by 2 plus t of n minus 1 by 2 plus n minus 1. Is that correct? Is that correct? Is that correct? But in the recursion, no, again, when we apply, both cases are possible. Both cases are possible. That's why what is that we can say is, can we say that t of n is less than or equal to 2 times t of n by 2 plus n minus 1? Simply.
Yes, we can write that.
That's better. No, so anyhow, we are trying for asymptotic bounds only, no? So simply it is better not to say this. So based on this, we can easily say that it is big O of n log n. Is that okay? Is that correct? Is that
Yes,
correct?
sir.
So similarly, we can even say that t of n is greater than or equal to 2 times t of n minus 2 by 2. This is also correct, no? Based on that, we can say that t of n is big omega of n log n. Combining these two, in this case, t of n will be theta of n log n, which is same as best case. Is that okay? Is that correct? Is that correct? Is that correct or not? So
Sir,
roughly,
when we represent in asymptotic notation and we write t of n equal to big O of log n log n, in the previous statement we written t of n less than equal to.
yes. Here because
So here we need to write equal to or less than equal to.
where this one.
T of n equal to big O of n log n.
Correct. This is equal to only. This is equals to only.
No need to write greater than equal to there.
No. Big omega itself, it takes care. No.
Okay.
Big omega means it is at least. It is double. No, double at least is not required. No. T of n is at least n log n. No. Then if I put greater than or equal to.
Okay, understood.
So instead of this, if I always take n by 4th smallest element as pivot, what is the reconciliation? Roughly, okay, we calculate roughly. We are not very much specific about +1, -1 and all. One side, how many elements will be there? N by 4 minus 1. What about other side? N minus 1 minus n by 4 minus 1. Roughly 3n by 4. Is that okay? Now, what is our reconciliation in this case? We can say that T of n is less than or equal to T of this n by 4 minus 1. I will consider it as n by 4. N by 4 plus T of 3n by 4 plus n minus 1. What can we say about its order of growth? If we draw recursion tree, easily we can show no n by 4 plus 3n by 4, it is exactly n. So height will be log n. So it becomes n log n. So every time if you choose n by 4 the smallest element as pivot, where n is number of elements in the array to be sorted, then what happens? Then what happens? It takes n log n time. That means it is same as best case, no? Is that correct? So median means which divides the array in which ratio? Left and right? 1:1 ratio or not? Median means n by 2 the smallest element, roughly. Is that correct? Is that correct? N by 4 the smallest element, if you take, it divides the array in what's the ratio? Always pivot, left to right. What is the ratio? What is the ratio? One side n by 4 roughly, other side 3n by 4. What is the ratio here? What is the ratio? 1:3. Can you call this 1:3 ratio?
Yes, sir.
So instead of this, if it is n by 5 the smallest element, if I choose, what is the ratio we will get? One side n by 5 roughly, other side 4n by 5. This is 1:4 ratio. Is that okay? So in other way, if the, okay, these are different cases we observed. Okay. Now, for example, if you know that always pivot, it divides the array divide means partition in 2:3 ratio. What is the reconciliation? What is the reconciliation for running time? Pivot always divides the array in 2:3 ratio. What is the reconciliation?
So T of
That means if
2n
there
by
are n
5
elements,
plus
if there are n elements in total, n elements, 2 parts will be one side, whether left or right, we don't know. 2 parts one side, 3 parts other side. So 2 parts of n elements is nothing but
2n by 5.
2n by 5. 3 parts of n elements means 3n by 5. Now what is the reconciliation? 2n by 5 plus a t of 3n by 5 plus n minus 1. Is that correct? So if we draw a recursion tree, what is that we can show? To be more specific. So T of n, easily we can show that it is big O of n log n, or we can even show that it is theta of n log n. Is that okay? That means if you know that array is always divided in the ratio 2:3, still its running time is n log n. Not only 2:3, even if it is 3:4 or 6:10, 6:10 means it is same as 3:5, no? 3:5. This become 3:5, both are same. In general, some L:/M ratio, where L and M are constants. L:/M ratio. If it divides in pivot divides the array in L:/M ratio, then what is the reconciliation? What is the reconciliation? How many elements will be there in the left side, one side, and how many elements on the other side? L is stem ratio means how many elements will be there one side? L by L plus M into N. Is that correct? What about other side? M by L plus M into N. Is that correct? So what is our reconciliation? T of L into N by L plus M plus T of M into N by L plus M plus N minus 1. This also we can show that its order of growth is N log N. So that means if the array is always divided in some constant ratio, still its order of growth is same as best case. Still its order of growth is same as best case. That means there are different cases in which it works very well. It works very well. Best case is same as average case, and still there are different cases where its running time is same as N log N. That is best case running time. Is that okay? Now, last case we discuss and then move on to other topic. For example, if the pivot is chosen such that first, if there are n elements, it divides like this. One side 0, one side n minus 1. Again, when there are n minus 1 elements, it equally divides. This is not balanced, no? Unbalanced, most unbalanced. This is n minus 1 by 2 elements one side, n minus 1 by 2 minus 1 elements other side. This means this we call it as balanced. Balanced means half, unbalanced means one extreme 0, other extreme remaining elements. That is unbalanced. Now, if the partition, if you alternatively choose pivots such that one time it is not at all balanced, next time it is balanced. Again, it is not at all balanced, next it is balanced. Again, it is not at all balanced, next it is very much balanced. Even if the array is partitioned like this also, still its running time is same as n log n. Same as n log n. So that means for most of the cases, it works very well. It works very well. So next, is Quicksort, is it in place or not in place? Quicksort, is it in place or not in place sorting algorithm?
It is in place.
It is in place only, no? That limit of partitioning, it is very much clear, no? It takes only 2-3 additional variables. That's all. That's why it is in place.
In place, yes.
In place sorting algorithm. So next, we move on to say square matrix multiplication problem. Matrix multiplication problem. So we confine our discussion to square matrix multiplication. Square matrix multiplication problem. So we are given two matrices A, Aij n by n, and B, Bij n by n, two square matrices. Okay. So what is B? What is AB? Our goal is we need to find the product AB. So when matrix multiplication is possible, one matrix is A, one matrix is B. When can we find the product AB? What is the condition it has to satisfy? What is the condition it has to satisfy?
Number of columns of first matrix.
Columns in A should be same as
Number of rows in B.
Number of rows in B. Then only multiplication is possible, no? That is in general, but a square matrices means automatically that condition is satisfied. Now, how to do this? Now, what is classical way of multiplication? What is the time it takes? Classical method? Direct method?
N cube, sir.
Classical. So I am not going to do that. Classical method. It is n cube. That means it's a theta of n cube. Is that correct? Okay. I just ask one question. This is not square matrix. This is say P by Q, P Q by R. If I want to find capital C matrix whose product, how many element multiplications we need to do? Number of multiplications required is how much?
PWR. P multiply W multiply.
How many multiplications are required?
P into W into R.
Okay, this is Q. Okay, P into Q into R.
It's Q.
Yeah, is this okay? I have written it. Okay, it doesn't matter. Okay, PQR. PQR. Is this correct? Is this correct? Is this correct? Why it is true? We have P rows here. Row 1, row 2, and so on. Row P. Q columns here. Column 1, column 2, and so on. Column Q. This is matrix A. Here we have row 1, row 2, and so on. Row Q here. Row Q here. This is a column 1, column 2, and so on. Column R here. So now if I want to find the element at this position, 1, 1 position, what is that we need to do? What is that we need to do? In the resultant C matrix, what is the order of C matrix? What is the order of C matrix?
P by R.
So because all of you know this, that's why I'm not elaborating all these things. Okay. So what is the order of C matrix? Is this P by R? Is it clear? Is that clear? Why it is P by R? Okay. Now, if I want to find this matrix, this element at first row, first column, that is C11, we call C11. What is that we need to multiply? What is C11 value? Please tell me. What is C11 value? In order to find the first row, first column entry, what is that we need to do? Here, the first row we need to multiply with elements in corresponding elements in first column. Is that correct? Is that correct? Then it gives us first row, first column entry here. Is that correct? How many entries are there in this row? How many entries are there in this row? How many entries are in this row?
Q, sir.
Q. Why? Because it has Q columns, Q entries. Now the same number of entries should be there in this column, no, first column. Whether same Q entries are there? Yes. Why? Because it has Q rows. Q rows. If I take vertically, so it is Q. So corresponding elements we multiply and take their sum. Take their sum. Is that correct? Now, if I want to find C23, what is that we need to do? C23. What is that we need to do?
Second row of first matrix should multiply with third column of second matrix.
Thank you. So in order to find C23, second row we need to multiply with corresponding elements in third column. Is that okay? This is row in first matrix. Column in second matrix. After corresponding elements product. Product. Then sum. Okay. Is it okay? So that's why, see, in the resultant matrix, P rows and R columns, how many entries are there? P by R, P into R entries are there. Now for each entry, how many multiplications do we need to do? 1, 1, 2, 2. Like this, how many we need to do? How many we need to do? How many we need to do? Q. So there are total P by R entries. For each entry, we need to do Q multiplications. Hence, total number of multiplications is P into Q into R. Is that correct? Is that correct? Is that correct?
Correct, sir.
Is that so? Now what is this? Is A matrix, this is B matrix. So then what is in C matrix? What is C11? Please tell me what is C11 in this case. What is C11? What is that we need to do? What is that we need to do? First row we take. Okay, or instead of C11, how to calculate C12? What is C12? First row we need to take, and the second column and corresponding elements we need to multiply. So what is C12? 1 into 6 plus 2 into 8 plus 3 into 0. Is this correct? Is that correct? So total how many multiplications we have performed here? Element multiplications. These are element multiplications, no? Element multiplications. How many we have performed? 3. What is 3 here? What is 3 here? 3 is number of rows in first columns in first matrix, which is same as number of rows in second matrix. Okay. So for each element we need 3. Like that, how many elements are there? 2 into 3, 6. 6 into 3 into 6 into 3, 18 multiplications are required in this case. Is that okay? So in general, we are given two square matrices A, n by n. So B, this is n by n. How to multiply this? Anyhow, we learn to divide and conquer. Okay, no? If there is only one element in the array, in the matrix, it is A is only 5, B is only 3. This is 1 by n, 1 by 1, this is 1 by 1. Is it directly possible to multiply this? What is the result?
1 by 1, 5.
15. That is 15, no? Is that correct? Directly we can multiply. If n is 1, n equal to 1, answer is direct. Answer is direct. Otherwise, what we do is this A matrix we divide it into 4 parts. 4 parts. Whatever elements are there in A, we divide into 4 parts. Whatever is there in B, this also we divide into 4 parts, 4 equal size parts. Then this one we call it as A11. This is A12. This is A21. This is A22. That means if n is more than 1, if it is 1, directly we calculate answer. If it is more than 1, we divide the problem into subproblems. How many subproblems? How many subproblems? How many subproblems? How many subproblems?
8 subproblems.
4.
4. A is divided into 4 parts. B is also divided into 4 parts. Now, what is subproblem means here? Subproblem means
Multiplication. Okay.
multiplication. Okay, subproblem means multiplication. Here our goal is, what is our goal? Find the product, find AB. Correct? No, that is our goal, no? That is our goal. Find AB. Okay. So yeah. Now what is C? This C also we can divide into 4 parts. This is C matrix. This we call it as C11. C11 is or A11, B11. These are again matrices. Okay. Okay, C22. Now, if A is n by n matrix, B is n by n matrix, automatically C is n by n matrix. What is order of A11? What is order of A11?
Big O of 1 is constant.
No, order means number of rows and columns.
Okay, n by 2,
The
n by
order
2.
of growth. Okay.
Yeah, n by 2, n by 2.
Is it clear why it is n by 2, n by 2? If there are six,
Yes.
it is 16 by 16, or okay, instead of 16, you take 8 by 8. If there are 64 elements, how many elements will come here? 16, 16, 16, 16, 16. This 16 I can consider as 4 by 4 array matrix. Is it okay? Is that okay? So that means order of A11 is this correct? Similarly, what is order of A12, which is also same? A21, that is also same. A22, it is also same. What about B11, which is also same? B12, here I assume that n is of the form 2 power k, k is greater than or equal to 0 for region analysis. Okay, for region. Is that correct? Is that correct? Is that now you tell me what is C11? What is C11? C11, it is a matrix. What is C11?
A11 into B11 plus A12 into B21.
That is first row we are multiplying with first column. Is that okay? Now you tell me what is C12? First row with the second column. First row is A11 into second column means B12 plus A12, second column means B22. What is C21? What is C21? What is C21? Second row, first column. What is C21? A21, B11, B11 plus A22,
B21.
B21. What is second row, second column? A21, B12 plus A22, B22. That means in order to find the product C, how many multiplications we are performing? In order to multiply 2 n by n matrices, 2 n by n matrices, in order to do this, how many we are multiplying?
8 multiplications, sir.
1, 2, 3, 4, 5, 6, 7, 8. 8 n by 2 by n by 2 matrices product we are finding, no? Is that correct? Is that correct? Not only that, after finding the product, whatever matrix we get, what is the result order of this matrix?
N by 2 cross
N
n.
by 2. What is the order of this?
Same.
Then we need to add this matrices, no? We need to add this matrices. What is the time matrix addition takes? What is the time corresponding elements we add? No, what is the time matrix addition takes?
So if it is n cross n, it is n square.
N square. So n cross n, A plus B, A plus B, A is n by n, B is n by n. Okay, if you want to find C, it takes how much time? N square. Is that correct? N into n, n square elements we need to add. Here, how much time how many operations we perform here?
So it takes n square by 4.
N square by 4. Is that okay? Now, what is total time it takes? T of n is how many subproblems we are solving here? How many subproblems we are solving here?
8 subproblems of n by 2.
Subproblems. Each of size. For this time is T of n by 2. Like that for each one T of n by 2. This is T of n by 2. Is that okay? 8 times T of n by 2 plus to add this. How many times we need to perform addition?
4 times.
Each addition, how much time it takes? N by 2 into n by 2. So this can be written as T of n equals to 8 times T of n by 2 plus n square if n is greater than or equal to 2. Here, what is that we have done? What is that we have done? In order to multiply two n by n matrices whose size is large, we have divided that problem into subproblems. We are solving 8 subproblems of size n by 2. Then their correspond with their results we are adding to get result for original problem. Is that correct? So T of n, we have got 8 times T of n by 2 plus n squared. Now, is it a divide and conquer algorithm or not? Is it divide and conquer algorithm or not?
Yes, sir.
What's the time this, which case of master theorem is applicable here?
Case 3.
No, sir. Which case of master theorem is applicable here?
Case 1, sir. Case 1.
Case 1. By case 1, what is T of n?
N cube.
Theta of n cube. Now see, we have applied divide and conquer method, but still we have got running time as same as classical way of multiplying the two matrices. We have done more work, no? If we do more work, there should be some benefit. But did we get anything here additionally? No. Instead of doing this, it is better to directly go for classical way of multiplication, no? Then there is no difference. Then how to improve this algorithm? It is divide and conquer algorithm, fine, but it has not given us any advantage. Its running time is same as
Classical method.
classical method. Now you tell me what is that we need to do so that it becomes better than
Classical method and
classical method. Any idea? You look at the reconciliation, automatically we get clue. Okay, let me ask that one question. Okay. Is it possible to solve a matrix multiplication problem in less than n square time? Square matrices of order n. Is it possible to multiply two square matrices of order n in less than n square time? Is it possible to multiply two square matrices
sir, as
of
per my
order
knowledge.
n in less than n square time? It is impossible. Why? Because there are total n square entries in the resultant matrix. That calculation itself, even if I assume that each one takes constant time, minimum it takes n square time. So we know that no one can do matrix multiplication in less than n square time. Is that correct? No one can do matrix multiplication in less than n square time. But we know that classical method, it takes n cube time. Now, how to get a method, how to get something method which is better than n cube? Definitely that better means it cannot be lower than n square, no? Okay.
I think that is dynamic programming, sir.
That is?
A dynamic programming, maybe the topic. Using.
No, sir, no.
Yeah.
Divide and conquer only we use.
Okay.
So somehow, if we can reduce the number of subproblems,
Yes.
will give benefit in running time.
Thank you, sir. So that is, now we know that definitely it cannot be less than n squared. That much clarity we have. It is not possible. It is impossible to multiply two square matrices of order n in less than n squared time. Now we know how to multiply by applying divide and conquer in n cube time also. Okay, without bothering about classical method, by divide and conquer, we know how to do that in n cube time. Now, what is the improvement that we can do so that it becomes better than classical method? What is the time matrix addition takes n square? Matrix multiplication takes square matrix only. It takes n cube time. Okay. Any clue? This n square, if I increase to 20 into n square, or whether there will be any change in the running time? N square, I made it 20
No, sir.
square. N
No,
square,
sir.
if I make it 18 into n square, whether there will be any change?
No, sir.
No, some constant into n square, it remains like this only. That means now we have 1 into n square. Instead of that, if I have 18 into n square, it no problem. That means what? You are performing more number of additions. That is the meaning, no? This quantity is for addition work, no? Instead of n square, if we have more than n square here, 2n square, 3n square, 5n square, 20n square, it means what? You are performing more additions. If it is some constant into n square, we don't have any problem. We don't have any problem. Okay. Now, instead of this 8, if I reduce this value to something smaller than 8, then what happens? Then what happens?
Let's reduce the running time.
Instead of 8, if 7 is there, running time is reduced or not?
Yes, sir.
If 6 is there, is it reduced or not?
Yes. Yes, of course.
5, 4, 3, 2, 1.
But sir, less than 4, you said impossible.
No. See, here
So
n
if we
square
reduce
is
to
there.
4, it would become.
Already n square is there. So definitely it gives me minimum n square running time. Whether I solve 1 sub problem or 8 sub problems, it doesn't matter to me. Automatically n square is here. So minimum time will be n square. No, sir, it cannot be less than n square. No. This
Yeah,
I am
that's
fixing.
So that's I'm telling you, less than 4, like 3 cannot be. No, it's fine. In that case, it would be a case 3.
Case
Okay.
3. Yes.
Yeah, it's great.
Okay. So now number of sub problems, if it is 1, what is the total time it takes by case 1 of master theorem? Case 3 of master theorem? N square. If number of sub problems is 2, by again case 3 n square. If number of sub problems is 3, case 3 n square. If number of sub problems is 4, case 2 it becomes n square log n. Is that okay? If number of sub problems is 5, 6, 7, all will be case 1. And what is the answer in these cases? N power log 5 base 2 or n power log 6 base 2, n power log 7 base 2. Is that correct? N power log 5 base 2, n power log 6 base
Yes,
2,
sir.
log 7 base 2, respectively. Is that correct?
Yeah, correct, sir.
What I'm saying, no, T of n is 5 times T of n, because we have done a lot of examples. No, that's why I thought. In this case, which case of master theorem is applicable?
Yes, case 1, sir.
Case 1. Answer is
N to the log 5 base 2.
if it is 6, instead of 5, we will get 6. If it is 7, instead of 6, we will get 7. Is that okay? Now, which is easy? Is it by solving less number of sub-problems to solve original problem is easy, or by solving more number of sub-problems, solving original problem is easy? If number of sub-problems we are solving is more, means we have many things in our hand, so that somehow we will get answer easily. If less number of sub-problems, no, that means we are discarding most of the part in the input, no? With the small part itself, we should get an answer to entire thing. That may be difficult. Okay, that may be difficult. That's why the option we have here is, though we have 1 to 7, the first breakthrough, it came at 7. That means they used only 7 n by 2 matrix multiplications to solve this problem. Then the reconciliation is T of n is 7 times T of n by 2 plus n square, and the running time becomes theta of n power log 7 base 2. Okay, no? That is nothing but Stresson's matrix multiplication. Okay, I stop here. After the break, we'll discuss. So again, we'll